Okay, one quick comment here is that just because you've, okay, let me go ahead. Okay, so one quick comment here. Just because you have found the point where the derivative goes to 0 does not automatically mean that that is the max or the min that you're looking for, right? So in theory, you're supposed to do the either second derivative test or tracing the see if the derivative goes from positive to negative or negative to positive to find whether it's a maximum or minimum. You actually have to do that, right? So I did not go through that, but that's something you have to do. You have to do that. And also, when you're looking for absolute max and min, also one of the things that we looked at were the endpoints, right? But in real life, when you're doing things like if you look at the CAN or the that kind of stuff, really it's never going to be at the boundaries or the endpoints, correct? Okay. So in real life, it's always going to be, usually it's going to be 99% of the time, it's going to be in an interior point. So, and that's, kind of what we were looking at, okay? But to do it correctly, you should actually be looking to make sure that the the point actually is a max or a min, and you have to make the tests or show that you did the tests to make sure that those are actually mins or maxes that you're looking for. Okay, does that make sense? Okay, so let's continue on. We're going to now talk about examples from economics, and that's on the very bottom page of page 227. So we're going to, in the business world, they want to always maximize profit, right? So if you flip the page to 228, in each thing, you're going to find a Rx and a C of X, where R would be the revenue. So this would be a function of the revenue, and this guy here would be the costs, okay? So you would be looking at these two, and you would be trying to maximize the profit, okay? If you go in the middle of page 228, it says, maximum profit, if any, occurs at a production level at which the marginal revenue equals the marginal cost. So the marginal revenue is going to be R prime. Okay, R prime is the marginal revenue. C prime will be the marginal cost. So if you find a point where this happens, that will be the maximum profit. Okay, so that's what you're really looking for, okay? So the trick, or the, not the trick, but the inside information, if you are planning to, put in a plant, a manufacturing plant, okay, you can actually look at these and find at what point you are going to derive the maximum profit, okay? And you would actually, and so you would build the plant accordingly to make sure that you are going to be able to have that production level, right? So if you make too small of a plant, you're never going to be able to reach that maximum profit level. Or if you build it too large, you're going to have a plant that operates at, half of the capacity to make the maximum profit, and you will never run the plant at more than 50% capacity. Well, then there's no point in building the plant that large, right? Okay, so this is actually a pretty, it gets used quite a bit in the business world. Okay, the problem is, and the whole trick is, how do you find the revenue, and how do you find the function for the revenue, and how do you find the function for the costs? Okay, that is the crux of the problem. Okay, so let's go ahead and see if we do example number 5. Suppose that Rx is equal to 9x and C of x is equal to x cubed minus that. So, okay, so let's go ahead and do this. So this is example number 5. Example number 5, we have Rx is equal to 9x, C of x is equal to x cubed minus 6x squared plus 15x. Okay, and we're going to maximize the profit. So we're going to see where R prime is equal to C prime. So R prime of x is going to be equal to 9, where C prime is going to be equal to 3x squared minus 12x plus 15. So you can set these equal to each other and see if we can find that. So I can move the 9 over. 3x squared minus 12x plus 6 is equal to 0. So if I divide everything by 3, I get 4. And I'm going to get 2. Obviously, this does not factor out. So I'm going to get that x is going to be equal to 2 times a minus b plus or minus square root of b squared minus 4 times a times c. So I'm going to get 4 plus or minus, this is 8, so I'm going to square root of 8 divided by 2. 2 plus or minus square root of 2. Okay, so if I do that, I get what? So this square root of 2, as Sam told us earlier, square root of 2 was 1.414. So I'm going to get 3.141, 3.414414, or 0.586. Okay, so you have 2 different points there. Okay, and if you do that, and so that's what you're going to get. Okay, right there. Okay. Now in the middle of page 229, it also gives you a different way, and this is now we're going to talk about minimizing the average cost. So the average cost, if I have a C of x, I know that's the cost, right? So the cost to make X amount of these widgets is going to be C of x. So the average cost is nothing more than that divided by x. Okay? So if I want to minimize this, so if I take the derivative of this, what am I going to get? What am I going to use? Caden. Caden? Caden is not with us? Or he is, but he's not listening. Eva.
The quotient rule?
The quotient rule. So I'm going to get, on the bottom, what am I going to get? X squared, right? Then low D high, right? Low D high minus high D low. D low is going to be 1, right? So I want to set this equal to 0. So what am I going to get? I'm going to get, so X, so basically the top has to go to 0, right? So I'm going to go X C of x minus C prime x is going to be equal to that. So it's going to be C of x. So this is going to be equal to 0. So I move this over. It's going to look like this. So what am I going to get? X is going to be equal to, so C prime of x is going to be equal to, in other words, if this guy is the smallest, I'm going to have the best. Okay, because I want to make this the smallest, right? And that's where we get the minimizing the average cost. When I minimize the average, I want to minimize the average cost. Okay, so let's see if we can do example number 6. Suppose that C of x is that, and so where is it? So I'm going to have what? So C I was told that C prime of X was equal to, we just found that, was that. So that's gonna be what? X cubed minus 6x squared plus 15x over x. So that's gonna be equal to x squared minus 6x plus 15. And you can set that equal to 0. So what am I gonna get? Again, this is not gonna be factorable. B squared minus 4 times A times C. Huh. What's going on here? X squared, yeah. Oh, so this has to be equal to the marginal cost. So this has to be equal to the marginal cost. So this guy here has to be equal to the marginal cost. So marginal cost right here, marginal cost is what? Is the prime of that. So it's going to be 3x squared minus 12x plus 15. 15's cancel out. I move this over, I get 2x squared. I move this guy over, I get minus 6x is equal to 0. So x is going to be equal to 0. So it's going to be either x equal to 0 or 3. Okay? But x cannot be 0, right? Because that means what? What does x equals 0 mean? That I'm not producing anything, right? We don't want that. So this is the one that we're actually interested in, x equals 3, okay? Okay, there you go, there you go. Again, so you need to find, when we're doing the business model, you need to find where there are two different things we can do, where the marginal revenue is the same as marginal cost, or you're minimizing the average costs. Okay? All right. And we are done for the